So, Glenson, I think you can start.
All right. Good morning, ladies and gentlemen, and welcome to the webinar on the future of engineering asset management, brought to you by the Asset Management Society of India. Asset management points at reliability, the maintenance of physical assets, with its implications on sustainability. With the changing business landscape, it is quintessential to know the transitions and be prepared for the future, to reduce costs, to mitigate risk, and improve performance. And rightly, we have this webinar to discuss the future of engineering asset management by Professor Gopinath Chattopadhyay. Welcome once again, ladies and gentlemen, to this webinar. May I now request Professor Raghuveer Pai, the President, to welcome the guests and the participants.
Good morning, gentlemen. It's my pleasure to welcome all of you to the third monthly webinar of AMSI. And we have this morning Associate Professor Gopinath Chattopadhyay, who is the postgraduate degree program courses in maintenance and reliability engineering. That's a MRE program at Federation University, Australia. And he's been a pioneer, a strong supporter of asset management across industries in Australia, and other places as well in India as well. So a very warm welcome to him and all of you as well. We will have Professor Chattopadhyay this morning presenting on a very important topic. Thank you.
Thank you so much, sir. May I now request Dr. Girish to introduce Dr. Gopinath to the esteemed participants.
Yeah, actually, Dr. Girish is just had an emergency, I think, in his family. He had to take his mom to the hospital. All right. So I just called him up and found out that he's unavailable. So I will do the introduction.
Over to you, sir.
Yeah. Professor Gopinath Chattopadhyay is a PhD in operations management from the University of Queensland, Australia. He is ME Industrial Engineering gold medalist in India, MBA Operations Management silver medalist from India, and is a BE Mechanical, again a gold medalist in India, an exceptional academic background. He has over 40 years of experience in industries and universities. He is currently the coordinator for postgraduate courses in maintenance and reliability engineering in Federation University, Australia. And these programs have been running since the 1980s with enrollment over 300 managers and engineers from reputed global companies. He was professor of strategic asset management, director postgraduate studies, and head of engineering postgraduate programs in Central Queensland University, and head of engineering management programs in Queensland University of Technology, Australia. He co-created the engineering management postgraduate courses at QUT, asset management in power generation, and further enhanced maintenance management course in the Central Queensland University, and maintenance and reliability engineering courses in the Federation University. He was principal consultant in asset management, Cardno, Australia. He has supervised 21 PhD and master's research degree students to successful completion. and has secured over 2.5 million Australian dollars of funding for industry-based research projects and published over 200 papers in reputed international journals and conferences. He is current chair of Asset Management Council Australia, a technical society of engineers Australia. Gippsland and international chair of asset management, that's he's a technical society of engineers Australia, Gippsland. So he's the current chair of Asset Management Council, a technical society of engineers Australia, Gippsland. So he's the Gippsland chair of Asset Management Council, and Asset Management Council is associated or is a part of the Technical Society of Engineers Australia. And he's also the international chair of Asset Management Society India. He was past chairs of Brisbane and Gladstone Asset Management Council Australia, past president of Australian Society of Operation Research, and vice president of Maintenance Engineering Society of Australia. Industry reviewer of ISO 55000 series of standards on asset management, total asset management plan of Queensland government, and reviewer of asset management landscape document for Global Forum on Maintenance and Asset Management, that is GFMAM. He is founding chair of International Conference on Maintenance and Intelligent Asset Management, that is ICMIAM 2020 to 2024. And today he will be speaking on asset management for reducing costs, mitigating risks, and enhancing performance. I present to you Professor Gopinath Chattopadhyay. Thank you.
Can you hear me?
Yeah.
Yes, we can.
Thank you very much. It is my honor and privilege to share some of the experiences what I had, and I'm fortunate that all these things were possible because of so many leaders in the universities and the industries, and many of you are in this audience. Thank you very much. A little bit of background of the program, what I coordinate. Maintenance and reliability engineering that runs since early 1980s, initially under Monash University, and then from 2014 under Federation University. Many of these engineers, managers, they're very experienced and they're working, they're good, but they're trying to aspire for the excellency. So these courses are online. They are flying out mode, and many of them, they work in remote places. So what I'll be covering, some of these are the work of my researchers and research students, and some of my fellow academics and industry professionals. So first thing is the asset management. If we go back to International Infrastructure Management Manual long days ago, and after that, publicly available specification, PAS 55, and then it has evolved to this ISO 55000 series of standards. There are discussions and debates into some of these areas, because earlier it was the asset, but now focus is more on what we do with those assets. And that is the value of those assets and realizing value from those assets. How those can help through this reliability, availability, maintainability, safety, and cybersecurity is also coming in picture because of the smart machines and so much of the interface along with the sensors, data, and decisions. So how asset management can help in terms of the reducing cost, risks, and enhancing performance? I'll share some of the personal stories, and then we'll come up with a conclusion that what we are trying to achieve, how that can make a difference, not only to the industries, but also to the communities and the world. So assets are just like any item, thing, or entity. Entity means something like the ether space or something, not the physical assets. It has value or potential value. So asset management is for retaining the value and realizing the value. That means what the assets are expected to do, whether they are doing or not doing. For example, if you look into the railway industries, they do not claim that they are the asset owners. What they tell that they are providing community service, helping people to go from one place to another place, safe, reliable, cost-effective, timely manner. Same thing for the freight, bringing freight from one point to another point when you need in a timely manner, cost-effective manner, and safety. That is very, very important. If it doesn't happen, this was one of the example in Dreamworld where 4 people died. There can be degradation, there can be problems related to integrity of the assets. There are tools and techniques and mechanisms. And at the same time, people, they take decision based on those. So have to make sure that you don't miss something, or even you find something, how quickly that can be fixed. So lessons learned in a hard way and opportunities for improvement exist because there are the regulatory requirements, and if those are not fulfilled, the operation can be stopped. And it happened in this case. There can be some cultural issues. In many organizations, you'll see that there is tendency of cut. I understand the cut of this budget is important. Sometimes the people, they become frustrated and they leave, and many times it's a short-term gain in terms of the deferment of the maintenance or the replacements, and that leads to the risk. Another example is if there is a gap between the two sides over the bridge, the quickest solution is that pour concrete, but that leads to additional loading. And if it happens that a train, because of the issues related to track maintenance, rollover happens and the train hits the pillars of that bridge, it collapses. So it is not just technical, it is related to processes, it's related to cost cutting in terms of the design verifications, and many times it is related to people, culture, and the leaderships. So this is this Grenville catastrophic failure example. Once again in Australia, people died, injuries, and significant amount of compensations, including people who were affected. So if you look into the four important areas for the asset management, one is the value from assets, not just cost and benefits, alignment of organizational objectives, leadership, and workplace culture, assurance that assets will fulfill their required performance. If you look into the picture, the above one is fish in the water, the below one is the butterfly. So when you are taking a decision, you need to understand the context of the organization. The butterfly needs oxygen, but from the air, fish needs oxygen dissolved in the water. So assurance part, once again, in terms of the policies, the procedure, working instructions, regulatory requirements, collecting that data, analyzing those things, and reliability, availability, maintainability, safety, and the cost modeling, risk modeling, performance modeling. Those things will assure, along with the trained people, motivated people, that things are working as expected and the asset will fulfill the expectation of the business. So there are the issues, like there might be some quick wins. First thing is that, is there any gap related to all these documented systems and in your capturing the capabilities of these assets? What is the remaining life? How much you can push the boundaries? Once again, there might be some of the options. What can be the to-be state? And what are the touch points? How to address those issues? Training, awareness, competence, implementation of continual improvements. So once again, this risk identification, assessment, and mitigation of those risks, stop structure, because it is a people who will collect this data, analyze those, interpret, and take risk-informed decisions. Once again, is that structure helping in terms of who is authorized, who is responsible, who needs to be consulted, and who needs to be informed. So in many cases, we see that those roles and responsibilities are not clearly defined, and there is a gap in the interface. Once again, maintenance risk management, what can go wrong? And maintenance organization for risk-based actions. Health and safety is becoming more and more important because of the regulatory requirement and expectation of the communities. Computerized maintenance management systems and enterprise systems, many cases are not updated properly. What data we are collecting? Do we need that? If we are collecting, are we analyzing those? Do we trust our data? Are we extracting information related to the life, related to the remaining life, related to the costs and risk? If you look into the cost, the total cost over the entire life cycle, definitely the capital cost and the operational cost and maintenance cost and whatever is the losses related to the consumption of the life and the disposal. Along with that, there are the risks based on whatever we are pushing the boundary, the operational and the environmental and the human aspects. So that puts additional risk, and there are the mitigations, the options, how we understand what is the current risk after those implementation of the interventions what is the residual risk? And many places it cannot be exactly quantified, and dollar figure might not be able to be provided, but still that needs to be considered and factored in the decision making. In a quantitative area like this live data and this fault tree analysis, event tree analysis, reliability block diagram, maintenance optimization, in my life, I can tell that global optimization is extremely difficult. Sometimes we do not know details about the entire problem, the environment, the operational, the human aspects. So these are some of the important things, and standards help to some extent to reduce the difference in the interpretation. Risk management, majority of the companies nowadays, they're aligning with this ISO 31000. There we need to identify the risk, prioritize that which one to be addressed first, second, and then third based on the available budgets. And once again, risk management in line with this documented system, along with the appetite of the board to resolve those in a timely manner, will help to manage the risk. Once again, the risk, we know that probability of occurrence and then the magnitude of what might be the consequence. Some companies, they try to average those things, and my understanding is that whatever is the highest risk needs to be identified and addressed first. Averaging will reduce the effectiveness of the risk mitigation strategies. Risk identification, analysis, prioritization, mitigation, monitoring. Sometimes risk cannot be mitigated. We have to manage that. So something can go wrong. If it goes wrong, how quickly the resilience will be back, how quickly the entire infrastructure of the plant will be in safe operating condition and provide the service expected by the customers, clients, or the communities. So there are the tangible and intangible aspects of the risk. Nowadays, more and more people are aware about the social risk. For example, if you are in any mining industry, development of the mines, operations, maintenance, and also the mine closure, what is the impact on the society? That land, water, air. Here in Australia, people coming from the First Nation background, they're asking that what the companies are doing to address their expectation of the connection to the land, connection to the water, and connection to the spirit. So that connection to the spirit is going beyond some of the tangible aspects, and those are the intangibles in this type of soft risk management. I call it this harder side of the risk assessment, how those can be considered in the decision making. There are the counterproductive KPIs. For example, if something is happening, you want to maintain that one, and it is managed in the local budgets, like the depots, the maintenance of the railway network. Then if something goes up, for example, you increase the non-destructive testing frequency, and that weeds out those potential risks, but that increases the cost associated with the depot, and then they will get a slap in the wrist for the budget overrun. But if there is a major catastrophic accident, derailment, maybe that is replaced by the capex and it is coming from the central fund. So see, there might be a counterproductive KPI. We need to look into the whole of the life cycle and the total cost. So data is another challenge in terms of the volume, quality, ownership, and trustworthiness of the data. In this risk analysis, many times those are disjointed, because I was conducting one of the work for some parts of Brisbane. It was in the Sunshine Coast. If your data is based on the plants in the south and the north, everybody is going to fight for their share for maintenance, but it is counterproductive. How it can be one set of the data, all these assets are under the same asset register, and risk management framework is developed in consultation with the people that, okay, if this STP is close to the communities, then it is a risky one. If something goes wrong, and then ambulance or some rescue can be quickly organized, then it is a less risk. If it is not, it is more risk. And also if something is fenced during the operation, when you open and people are going below to check and fix some of the things, then there is a less risk. And if it is not, then there's, so if you develop contestable and community accepted criteria, make it open and transparent, and then allocate based on the need, not based on some of the perception or disjointed way. So what is needed is sometimes the standard framework may not work. We need to develop the framework which will be useful for proper investment, and maintenance is based on the needs, not based on the perceptions. So there may be plenty of data. There may be limited analysis. There may be quality issues of this data. Data may not be maintained up to date. Limited feedback to data providers. Expectation that information system will solve everything is too much. IT solutions often over optimize, and then corporate versus local system, these are disjointed, sometimes over reliance on tacit knowledge. Knowledge sharing is limited. One segment of the plant is not aware that another segment has solved that problem. For example, in one of the steel plants, the 6 different units, one unit, they have provided a tertiary electricity supply. For example, the primary one is from the main source, secondary is the generator, tertiary is with the battery. So other 5 did not know. So the magnetic chuck, which is lifting hot scrap, that can fill, but in one of the plants, it was not happening. So once again, this knowledge sharing is very important. Consistent data definition, and that is why the standards are useful, that whatever is understood in Australia, same thing can be easily understood in Middle East or Europe or any parts of the world. Over reliance on single source of data. Sometimes, we trust the data so much that we forget that there may be change in the weather, in one day there can be 500 millimeter of rain, and data what had before that did not consider those things. Same thing related to cost data. For example, there is one data which is close to, say, more than several $100 million worth of the cost, and the data is not in the main database. It is in a separate manual one because of the political or legal reason. But how we can have those information in the cost modeling and decision making? Otherwise, the amount which is for the expected cost of derailment or accident will be less than the actual cost, which can go significantly up. So there are the issues related to the disruption we have seen during this COVID period in terms of the just-in-time supply was not useful because which was going to take maybe 6 days. The time was taking nearly 6 weeks. So that was one aspect. There is geopolitical disruptions because of the war or because of the some trade restrictions or even some broader restriction issues. And then you have shortage of the skills. You might have the new technology, but technology may not be available. So supply chain disruptions and failure to comply with the regulatory requirements based on changes in the restrictions, sanctions, all these things create additional risk, and those are needed to be considered in asset management decisions. Cybersecurity is playing a big role nowadays because machines are smart and they are operated remotely. And if something can go wrong through this cyber threat, that can lead to catastrophic consequences. Risk of complex network, sustainability and environment. Communities are expecting more in terms of minimizing the waste, adopting eco-friendly practices, and then aging assets, capital-intensive assets. Organizations are being forced to push the boundaries for the life extensions, managing those spares that may be obsolete. You have to develop those things and to upgrade those things, and how much you need to do to reduce the risk of operation of those aging assets. That is becoming more and more challenging. Let's come back to the risk management principles of ISO 31000. It is the value creation and protection and continual improvement. It's not one time. It needs to be done on a regular basis. Same thing related to risk identification. How we make sure anybody might be able to identify whether it is a valid or non-valid. That needs to be decided, and it has to be in this process. Then analyzing those risk and then risk evaluation. For example, in one of the power plant, they changed the process that anybody, even a visitor, can identify any risk and put that in the system in an easy to place manner, and then those are regularly analyzed. So whatever is detected, your maintenance and operations, whether that can be combined in the next overhaul or that can be used in the capital expenditure like these replacements. So these are the things needed to be considered in this risk treatment. Can you avoid that one? Can you transfer the risk to someone, maybe through the contractor or your original equipment manufacturer or subcontractors, you may not be able to eliminate some of the risk. Then what are the procedures? What are the resources? What are the strategies to bring it back? So like this weather change, like this huge amount of rain, flood, and cyclones or earthquakes. So those are the things we need to consider for bringing back the plant or the safety of those plants and bringing back those infrastructure to operation. So that is resilience part of the equation. So in this risk, what can go wrong? What are the potential consequences? How likely that can happen? Is the risk tolerable? And if it is not, how much it will cost? And again, those options, generation, analysis, and then implementation. Not only in one plant, it can be rolled out in a systematic way to the entire operation. This is one example. You can go to the Google and type that. That is a Glaston power plant case. I think around 2007, the power plant had lots of issues related to the availability. And these are the people like Glenn Shoemaker, there is Ben Hedin, there is Malcolm Leinster. So the general manager had decided how asset management can be overarching for the business driver. So once again, the leadership and culture, how people, they develop a documented system which people will read, they will know exactly what they are doing, why they are doing that, and what difference and the value adding from their activities. So they had this documented system and then going through easy to understand those policies, working instructions, procedures, along with capability building. Even people from the HR, people from the finance, people from the security even, they were trained to understand what the other parts are expecting and how they can be part of the solution. So once again, from this 2007 to 2010, there was a turnaround. 2012, they were awarded the Excellence Award winner by Engineers Australia in the asset management. So this is something how the leadership and culture can make a significant difference in reducing cost, reducing risk, enhancing performance. I discussed about these key performance indicators, how these key performance indicators can be counterproductive. Now, the example what I was talking about, this non-destructive testing. For example, if you are working in a sub-zero temperature, minus 40 degrees, you know that with this ice and snow, you cannot do this welding, or if something goes wrong, you can still manage by a fist plate and you have to increase these inspection frequencies. But if you increase more than one NDT before this winter and after that one, then you weed out some of the potential problems that can add this maintenance cost, but that can lead to the reduction of the cost of replacement and the accidents. We all know about the Hatfield case where this rolling contact fatigue, that was the engineering reason. But when deregulation happens, there is a tendency to reduce the cost and push the boundary by deferment of the replacements. So when we increase the axle loads and this same load off and on goes again and again, the cyclic one, the fatigue is created and then surface cracks develop. If the cracks are not detected and fixed, then that can accelerate, and undetected one can lead to the railbacks, and derailment can happen. It can go up to $10 billion price tag. So maintenance interventions, once again, there was in Queensland, some of the smaller grinders, you need more than one pass to grind those surface cracks so that you are throwing away life, but you are slowing down the acceleration of that crack propagation. That is why you are retaining significant amount of life. So justification of very expensive grinder that can lead to grinding in one pass, and that can also reduce the blockage of that corridor. So one way you are adding cost, but another way you are saving money. Same thing, it can be related to the rail carb lubrication. So these were some of the projects in Queensland Rail, and they had these test carbs in Gunela area, and the lubrications were tested in the Mount Larcombe area. You have several number of applicators like mechanical, hydraulic, electrical. So they are of different costs, and you have different types of lubricants. If everybody is claiming that it is working, and in 1 year you can find that the cost of wheel overrun may be more than $100 million, then something might be going wrong. So cost is going up because the risks are not addressed, the risk related to the wear of the track and wear of those wheels. Once again, when you have some of the defects in your plant, then you create that works order and you mobilize people, you have spares, then you implement that maintenance, and after that you close out the works order. If you conduct one survey with your organization that how much we are utilizing our enterprise system, you might be surprised. This was the organization in one power plant, and there they found the utilization was very low, and people had some of the legacy systems till that time in the Excel, some data in the paper based, and people had something in their head. There is a question why this is not utilized, and the answer was surprising. The answer was that there was not sufficient training, and corporate was investing in the training, but the training was not followed up when they needed to complete those actions. Sometimes they were struggling and they find some way out to manage those. So that is one thing. So train the trainer that reduced that risk. So they were able to fix that problem, follow the processes, and only one process can be followed throughout the organization instead of 7 different processes for the same defect identification and rectification processes in the enterprise system. That is one item. Second thing is that sometimes you can find that capital expenditure that is a very tedious process. It goes through different barriers and sometimes lots of questions in the board level. So smarter way, you can split it into a couple of OPEX that is just below that threshold. But one way you are managing that one problem, but you are creating another problem. The organization is missing out the benefits from the capex in terms of the depreciation and claiming that in the taxation. So these are some of the counterproductive activities in this maintenance and the asset management. Once again, when you have this data, you analyze that, you can see that many places there at the tail end of the data is like problem not found. So if you analyze the data as is, you'll find that, okay, that was given something like this log normal distribution. But if you take that off, clean that, then you see, no, it might be like the Weibull model. Sometimes you may not fit the data to any of the standard distribution. My way is better to have a crude contestable model rather than having a sophisticated one, which is not useful and not solving that one in terms of predicting correctly. So maybe like a probability of mass function can be a crude method in terms of analyzing those things. So that's why when you have some of the detection technologies, there is a cost associated with that, but it will weed out some of the problems. It can detect just by combining different technologies like eddy current and also the ultrasonic testing. So subsurface and also surface level, they have better accuracies, and that can lead to the cost associated with the inspections and taking out the risk, but it can take out the bigger risk of these catastrophic failures or derailment. So that is how you need to analyze how you can balance in terms of the cost, risk, and that can lead to the performance in terms of the reliability, availability, maintainability, safety, and reduction of the total cost of the operation and maintenance. So this was another example where the remote performance monitoring system along with the solar operated applicator was very expensive. But if you analyze the cost of this manual or hydraulic one, that was less. This one maybe 7 to 10 times more, but that can intervene quickly where something has gone wrong, like lubricant is not there, or there's a clogging, or some vandalism has taken place. So those types of things can be taken off, and the system can send maintenance people timely exactly when something has gone wrong, instead of waiting for 2 weeks and going there find that, oh, this was not operating and the life of rail and the wheel has gone significantly during that period of time. So this is another example. Environmental and social governance. I'm coming to the softer side, which I call it's a harder side. Communities are expecting more. The example I told in terms of the connection to the land, connection to the water, and connection to the spirit. That is coming from the First Nation people related to the mining projects and mine closure and rehabilitation. Environmental stewardship. So there is concern related to this biodiversity, some of the waste management, whether some of the materials are contaminating the soil, air, and water. Those things are becoming vocal. And then climate change is happening in terms of the huge amount of rain in one time, or that is huge amount of heat or cold. So those are impacting on the assets, and we need to make sure the assets are future proof. Again, softer areas, which is the harder areas, the cultural heritage. This is one of the cases you can go and check in public domain. 46,000-year-old site was destroyed. And that is a huge risk. How we can detect those things, how we can retain that in the system for any future operation, how that is not going to happen. So this was with the mining company, and even the chairman had this consequence. There was adverse impact of this with the company, and we need to understand how those things can be considered before any future actions. This is one of the good side, like when there is a mine closure and rehabilitation. Before that, the transition from coal, this is the Collie example in the Western Australia, where there was the coal, then related to industrial, agricultural, and aquaculture, tourism industries, how that can be developed so that post-coal, the impact on communities is less. So this is one example of how you identify risk, involve the communities, work with them, and find out solution so that risk associated with the communities are minimized. So this was the after transformation of that. And then related to this social risk, we need to understand there may be too many stakeholders. Sometimes it is difficult to quantify risk. Sometimes you'll not be able to quantify. Some of the solutions, if you take, it can be irreversible. It's not that, oh, you experiment with this and then we see that what happens. You cannot change it. Every problem may be a symptom, and that can lead to another problem. And many times there are the regulations. So we need to understand that in those cases, social risk needs to be identified, they need to be qualified, they need to be considered in any of the decisions. So Earth provides enough to satisfy every man's need, but not every man's greed. So that was statement by Mahatma Gandhi. And related to the asset management, whether that is plant and machines or it is these mining assets, we need to keep that in our mind. So in conclusion, what I want to share that good practices in asset management is very, very important. Once again, compliance or regulatory requirements, that is important. There are the ethical aspects. And most of the time, what we think that we are good, but good is not good enough in today's competitive world. We need to strive for excellence. And for that, there are the technologies, tools, there are the systems, and competent people. It is people who make it happen. Next point is the value, not just ad hoc basis decisions. Decisions need to be based on value and not just cost and benefits. And improvement opportunities are there. What do we need to do? We need to find it out and realize that in a systematic way. I bring this, the term of Jagga, that was in Sanskrit in the Bhagavad Gita. It's very old statement where it needs to be sacrificed, and that is a duty. So we are the engineers, in the asset managers, maintenance people, we need to understand we have a responsibility, and we need to understand the synergy of the environment and the natural cycle. For example, we create the fire creates the rain. Rain goes to the soil and the river and the trees, and again it goes back with the cloud. So that is the cycle. If we break the cycle, the natural cycle, there are the consequences. So in the asset management, we need to understand that natural cycle. We need to look after the soil, the water, air, and the universe. There is no wealth like knowledge, and it is excellence which matters. So I give this example of this Taj Mahal. If you see that picture is in India. That is example of excellence in any building. Beautiful, similar like building is there in Calcutta, which is Victoria Memorial Hall. But if you see both, Taj Mahal is Taj Mahal. Victoria Memorial Hall is not exactly like Taj Mahal. And again, some of you might go to Calcutta during Durga Puja. That is a festival where you'll see some of the pandals are created with the cloth and bamboo. They look like Taj Mahal with the lights. You take a picture, you say, wow, but that is the pandal. That is the bamboos and the cloth. That is not even Victoria Memorial Hall. So choice is yours. Whether we want to do this in a very quick shortcut way, or we want to do that in a hard way to understand the assets, do what is needed, not only for the organization, but also for the people and the environment, so that the world is a better place to live. Thank you.
Thank you. Thank you so much, Dr. Gopi. It was a pleasure listening to you. You spoke about how asset management is more of retaining the value and the implications of not having them. And I really love the fact that you said, asset management is not just about technology, but it is also about, the process, design, and culture. And you took us through the different steps of risk management, a walkthrough on the ISO 31000. And the fact that you actually garnish this with a lot of case studies is something that it makes, it really cherishable. And you also discussed on how do we interpret asset management report and the implications of environment and social aspects to asset management. Thank you so much for such a detailed and enriching discussion. I would like to take this opportunity to thank you once again. It's time for us to have question and answer. If we do have the audience with questions, you can either unmute yourself or you can post the same on the chat box.
Hello. Gopi,
Yeah, we can hear you.
can you hear me?
Yeah, we can.
Yeah. Gopi, thanks. Thanks for a very exhaustive presentation on asset management. I have one just simple questions, or rather, I've been wondering, is there any standard for dealing with the black swan events in context of asset management?
No, that's a very good question. And I mean, earlier people used to tell that there is no black swan, but there is black swan.
There
and
is, yeah.
that is that is
Or
the
rare events, you
that,
can call it, yeah.
yeah. So
Rare
that
events,
is, yeah, that is those rare events. And I think people are trying to find the answer, but again, it is based on some of the cases where that is the, if we understand the physics up to certain stage, that is fine. But if we go even to the molecule level or other places, many times we do not know many of the things. For example, even in our the human asset in the brain, if you look into that, how much we know, how much we do not know. So the short answer is I'm not aware of. And another thing is that there is a need for that one, and we need to work on that to find out that how we deal with that black swan. Thank you.
Yeah.
So if you kindly share
just
some of the things, that'll be great.
Yeah, one more sort of small questions. Actually, we
Sure.
touched upon many things, but one thing I think we should also look about technology-induced risk. There is a nature-induced, that was a black swan or human-induced. But what is the technology is bringing, the new type of risks? We are discussing a lot, and don't we need a lot of guardrails, guide rails, how we can steer into the right directions and all? Do you have any? Actually, European Union is working on the what we call like a new technology, and Varsa's asset management.
Yes,
So you need a lot of guardrails actually.
that's right. That's right. So one is that guardrail, but once again, I am discussing that. I have shared that with you also, that many times it is the people who take the judgment and they do that one. How we can have that one in their brain when they're in the kindergartens, when they're in the primary school, so that they're tuned to whatever is right and not to justify or create something. So technology, once again, I might be a little bit traditional. It is for people, it is for the universe. We need to respect that, and we did not create those things, and we can manipulate those things, but we need to be careful that for the short term what technology is doing, if that is adverse impact in that cycle, that can be a catastrophic change. So yes, we can do that. We need to have those guide rails, we need to have those barriers, we need to have those protections, so that, but at the same time, when people are thinking about designing, creating, in their mindset, if we have some of these things, that it will be foolproof as much as possible, that is the best option. But once again, that is a philosophic sense in terms of when you are designing, you are doing something like the rishis used to do. But many cases, that is not the case. So I don't have any answer. You can
Okay,
suggest some other
thanks.
things.
Just for keep on thinking. Thanks.
No, that's true. Those are the things that, like right now, in my understanding, that I'm thinking in that line of the social risk and those things, and raising that thing, that the harder one related to these data and the analysis, those things are really difficult, and still we are getting better day by day. But what happens with the people's expectation, the communities, and the natural cycle? So I do not know. So that is where we researchers need to work together to find some solution which will really make the world a better place to live. Thank you. Thanks for asking those
You introduced
questions.
one good thing. I will highlight it, that business model related risk you introduced like a Hatfields and all when you postponed the maintenance. But we'll discuss. Thanks a lot.
Thank
There are
you.
many risks we can talk.
That's true.
Any more questions? Yeah, I think I just want to ask about risk, and I think you put out ISO 31000. Very important. How risk is managed is going to be a part of asset management, no doubt. But then I think first we have to understand what is this risk, and given a particular situation. Any thoughts on how the risk management can be a part of the asset management, and people should realize that it's one of the important aspects of asset management?
Sure. I think, thank you for this question. In the risk, what I tell, there are three things. One is that claim that, oh, this is a risk-free, or we don't have any risk. Another one is perception. People perceive sometimes that, oh, this is risky. And then that is fact. many times we don't know what is fact. So these are the three things, and that is where the science is coming with the degradation models or these failures and the statistics, mathematics, the sensors are there. They're helping to get some of the data, what is likelihood, and then we have some of the information related consequences. But many times when we design those things, we do not know the consequences. For example, the asbestos case, that was a fantastic product. And then even in terms of some of the this sandstone and those types of things. But over a period of time, it was found that, oh, we did not know. So that is one aspect. I mean, they say in the risk, many times we do not know what is fact. Many of the things are based on the perception and claims. And sometimes the claims, they have some of the vested interest, and the perception is based on the ignorance. So far we can reduce those ignorance with the scientific facts and this data and the analysis. I think that is the first step. Another one is that, once again, the human mind, we have the will in terms of, if you tell something, I can accept, I can reject, and I can accept partially. I do not accept fully. So that is one thing. And next one is that people, they want to take risk, because people, they want to conquer the unconquered. Because if people are not taking risks, nobody could have gone to Mount Everest. So these people, they want to take risk, conquer the unconquered, whatever has not been done, technologies, new technologies. Now, in these cases, my suggestion is that we need to take calculated risk. So we have to take decisions. And if we train these students from the schools and then in the universities, and then all these assets, not only the physical assets, financial assets, information assets, human asset, and also the reputation, intangible, those things. I know, and you are also part of it. We are pushing the boundary after the spiritual assets. That is what. So what you are asked, that it needs to be embedded into the asset management. It's not just the physical assets, but all sorts of assets. And I use one of the sayings of the old rishis, that our purpose is for Atma Moksha and Jagat Hitaya. That is in Sanskrit, means all these engineers, managers, we need to aspire for making things better, doing something uplifting ourselves. And Jagat Hitaya means whatever we do is adding value and the betterment of the universe, not only just human being or the plants. And so it is about the universe. So philosophic sense, I try to answer your question.
Yeah. Thank you.
It's a difficult thing. Thank you.
Yeah,
Yeah,
Gopi, there's one
sure.
more question by Abdul Majid. Mazid. Thank you, Gopi, for the great presentation. Wondering how we can compromise risk and asset availability.
Oh, that is it. Listen, if you ask me that question, that risk, people don't want to compromise, don't have to, but many times, there is like you have two of the bad things, then you have to accept which is a less bad. So that is the one thing. And second thing is, sometimes that there is a constraint in terms of the budgets, and something is the best solution, but you cannot afford it. So you have to take the second best. So the value of the money invested, and that is how, in terms of what is your current risk, how much you are going to reduce, and then how much is going to cost, and then cost divided by that, how much reduction, and that gives you the ranking. But once again, Majid, at the end, people will take decision based on their inclinations, liking, their conscience. So even something is expensive, people find that that is a value adding based on sometimes their ethics, sometimes their culture, sometimes their spiritual alignment. People are ready to pay more for some of the interventions. So there is no hard and fast rules. And if that was just based on the scientific, analysis, then I think people would have been different. I'm not going to tell better or worse, but could have been different. So yes, as a manager, they might have to take a decision based on the available resources, funding, and the information, and there might be something related to alternatives. I'm not just telling that is a compromise, but that is a calculated risk. Thank you.
Uh, uh,
Yeah, thank
Professor
you.
Gopi, may I come in? On
Yes,
this?
please.
Okay,
Yeah.
firstly, a brilliant presentation, Professor Gopi, very nice. Now, I would like to share this thought. Basically, when we say risk versus availability, now there are two examples which straight away come to mind. In the Air Force, we have these Avros, which are flying machines. So initially, we used to overhaul the engines after every 250 hours. And then we did some kind of analytics by putting some technology, basically some sensors, including the um, uh, torsion vibration sensor and others. And over a period of time, we started overhauling it at 650 hours based on condition monitoring. So 650 was the earliest that we saw. And therefore, we realized that over the years, 400 hours of useful flying, we actually did not capitalize on with what you said, claims or maybe perceptions, but not based on facts. But when you have technology in hand, it makes perfect idea to start using, modeling and simulation studies based on some data that you may have, or physically using these sensors. The second example I want to give from my army experience is on tanks. We were overhauling tank engine again at about 450 to 500 hours of service, because we realized that for operations we need tanks which could actually have so many hours, almost 500 hours available whenever they happen. And therefore, we had this conservative thought till we use the torsion vibration sensor in our engines. And we realized that 1100 hours was the earliest when it started showing signs for an overhaul. And there again, it was still in the amber zone and not really red. So
Sure.
then we realized that, almost 600 hours of useful life we've been sacrificing because of our claims and perception, what you correctly mentioned. So really speaking, I think technology-based data analytics can really help. And
Yes.
Looking at modeling simulation, because today a lot of these computer-aided engineering softwares, computer-aided design softwares are available. And if you can pull out data, I think it gives you adequate risk management on the one hand and optimum availability on the other. So I think if we involve ourselves at that level of looking at technology as an enabler with data analytics, we may get the best answer. This is my sense.
No, I think
Thanks.
I think you are right. But at the same time, see, what you are telling, that is the ideal one. But I'm telling, for example, in Australia, in submarine, you cannot get it replaced in the next day, or so sometimes the data is not available because so many years and so many contractors, subcontractors, and some is with the OEM data in a different form. So what you are telling in the ideal sense, that is great, but what Majid is telling many times, you do not have that failure data itself. So that is another thing. It becomes challenging. And another one is that, for example, you have your mission critical asset and you do not have the spare parts. So you scavenge from the another one. You know that you are taking risk, but you are compromising that. So that is another thing. Or you have a clone parts, but because if you don't do it, risk is more, total stoppage compared to that. So it is very, very complex, and that's good that this talk has created some of the discussions, and we can continue with that in the future. Thank you.
Thank you so much. Do we have any more questions? All right. So, sir, do we close the session?
There's a vote of thanks by
Yeah.
Dr.
I
Ganesh.
now request Dr. Ganesh to propose the vote of thanks.
Hello. Hello. Hello.
Yes, sir, you're audible.
Hello. Am I audible?
Yes, you are.
Yeah.
Hello. Good afternoon, everyone. On behalf of AMSI, I extend our sincere appreciation to Professor Gopi Chattopadhyay for his insightful presentation on asset management for reducing costs, mitigating risks, and enhancing the performance. We are truly grateful for the time and effort he invested in sharing his valuable insights with us. This presentation has not only enlightened but also left a lasting impression on our minds. Thank you, sir, for delivering such a thought-provoking speech. I would like to extend our heartfelt thanks to our distinguished guest, Dr. Raghuveer, President AMSI, and others of AMSI for gracing us with their presence. Your support and encouragement is appreciated. A special acknowledgement goes to the organizing committee whose tireless effort ensured the seamless execution of this event. Dedication and hard work were instrumental in making this event a resounding success. I want to express my gratitude to all the participants and attendees for actively engaging with us during this webinar. Your participation is invaluable as we strive to elevate the understanding of asset management concept to the next level. Furthermore, I extend our gratitude to the media, sponsors, and partners for their unwavering support. Without your commitment, this event would not have been possible. To every individual who role, large or small, in making this event successful, we extend heartfelt thanks, and also I extend my heartfelt thanks to Master of Ceremony, Glenson, notice, and we truly grateful for your for the knowledge and inspirations received. Together, continue to opportunities for collaboration and strive for continuous success in future. Once again, thank you all for participation, and we eagerly anticipate seeing you at our upcoming event. Have a wonderful day.
Thank you, Dr. Ganesh, for presenting the vote of thanks. And thank you, Glenson, for doing the Master of Ceremony at very short notice. Thank you all. We had a wonderful presentation and quite a few questions. We meet for the webinar next month, that is in April. I think it's 20th of April. Mr. Ashek Prabhu will be speaking. He has yet to send me the topic. Ashek Prabhu is from Melbourne. He has his own company, ACEAM, and they work in asset management. And I think Siemens has taken over that company, which he's co-founded. So thank you one and all.
Thank you. Bye.
Thank you, ladies and gentlemen. Have a great day.
Thank you very much. Okay, bye.